Hello everyone, welcome to Java Tutorials. My name is Kishore. In this video, we will discuss one more type of collection interface, that is queue. Queue is used when an application already has the data that needs to be removed for further processing. The queue interface provides one method called poll, which is used to remove the element. When queue needs to remove the element, the application must already have the data. Only then you can call the poll method so that the removed element will be processed. So there are two implementations in queue, linked list and priority queue. The linked list implementation removes the elements in first out order, which is also called as FIFO. Then the priority queue removes the element in sorted order, that is the priority in priority queue. So when you can use linked list is, say for example, you have some sequence of messages which are maintained in the application, but that needs to be sent to some user. Now, if there are some 10 messages, you need to send one by one. In that case, you have to send the first message arrived to the application to the user, correct? So you need to remove the first message that came first. Similarly, for priority queue, if you want to remove the element in sorted order, say for example, you have some medical related items like medicines, and you want to clear the medicines which are nearing to the expiry date. Then you need to sort the medicines based on the expiry date, and you need to remove the one which is nearing to the expiry date. And also another example, like you can take a bidding example. User is bidding some items, and if there are some set of orders which are already there in the application, you need to check which is having the highest bidding price. That needs to be processed first. Then you need to remove those elements in sorted order based on the bidding price. Then priority queue would be useful. Let us take a simple type for linked list and priority queue and see how it works. Then we can discuss how it works in complex types also. For linked list, I will take queue as the reference. We will take integer queue equals new linked list. Then we will add some items like add 25, add 35, add 10, then add 15, add 30. If you want to remove the element, you need to use poll method. So if I print the element that is polled, what it is going to print, let's see. Polled equals q dot poll method you need to call. If I run this program, I would see 25 because that is the element added first. Before poll, you can also print the q by using system.out.println. You can just print the q so that every time you poll, what is the element left you can see. Now the queue is displaying all the elements. After polled, it has to, let me print this, it has to print the one which is removed should be not there and other elements should be present. Next again, if I poll, let me run the program again, you can see 35 is polled. So this way the linked list is going to remove the elements in first out order. Same program I can change to priority queue also. So how does the priority queue removes the element in sorted order? You just need to change this implementation to new priority queue. Let me create the object of new priority queue, and if I run the program, let's see how it works. Observe the elements that are printing are 10, 15, 25, 35, 30. That is not the way you added the element. It is partially sorted. It needs few top elements to remove first. You can observe the pole is removing 10, and after that it is removing 15. Next, again, if I call the pole method, it has to remove the next element sorted is 25. So this way it is actually sorting and removing. That's how the priority queue works. Next is, what if you want to add complex types to linked list or priority queue? First, we will check the complex type for linked list. Then we will see the complex type adding for priority queue, because we are going to use one implementation of comparator for priority queue, because by default the priority queue sorts in ascending order, but it can only sort simple types. If it is complex types, it will raise error. First, we will see linked list. For complex type, what I will do, I will use one class with the name called message, and we will create two properties, ID, and one more is name. Let me generate setters and getters, and let me also generate constructor here, constructor using fields. We will generate a toString method also, and a default constructor as well we will keep. Now let us store the message based on ID and name. The message should be stored, but it has to remove in first out order if it is in linked list. But if it is priority queue, we will try to remove in sorting order, maybe based on ID or maybe based on name. We can sort and we can remove. So let us first add the message. For this, I will create one new class with the name called test queue complex type, and we will write a main method here. We will create an object of linked list first to maintain message, linked list, and we will call the add method and pass the message object. We will pass some ID like a 2, and this is the message. Then few more messages we will add. I will just copy paste. This is message 1, this is message 3, this is message 5, and this is something like this. Next, we will try to poll. And when we poll, what happens? The first element that needs to be removed should be the first one you have added, that is hello. So to poll, what you can do, you can use first we will print the message, and then we will poll. Poll equals queue message dot poll, and we will print one delimiter. Then again I will print and I will poll. So if I run the program, it has to remove in first out order. These are the messages. It is added in the order how you have inserted, because it is linked list. You can observe here the last element is 5, that is the last element. Before that 3, and before that 1, and the first element is 2. But polled is 2 because that is the first one added. The second added is the ID 1 high, that is being removed. So that is how the linked list removes the element that is in first out order. But what happens if you try to add this message object in the queue? Let's try to check. Let me create an object of priority queue, and if I try to run the program, I get an error called class cached exception. It says message cannot be cached to comparable. Either you implement comparable in message class and override the compare to method, or you pass a comparator implementation as a parameter to the priority queue constructor here. So that, so you need to actually pass the comparator implementation here. We already know why comparable or comparator is used. Comparable and comparator gives you the methods that would return an integer value. So you can actually, the sort method actually can use that to sort. So let us create a lambda expression like this. So I write m1 comma m2 and I want to compare based on ID. So in that case, what happens is m1 dot get ID, you need to pass it to the integer. Integer dot compare m1 dot get ID and m2 dot get ID. So you are passing the comparator implementation such that the comparator would get the positive, negative or zero based on two message IDs. Now what happens if I run the program? If I run the program, see the priority queue has added 1, 2, 1, 3, 5 and it is already sorted. And when you poll, you can observe the first element that is removed is 1, the second element that is removed is ID 2. So this way, based on the priority queue removes the element. But if I interchange this, m2 dot get id and m1 dot get id, now in descending order it is going to remove. That is 5 is removed first and then the 3. You can also remove the message based on the message content. In that case, what you can do, you cannot use integer. So you need to use the compare to method of string class itself, because string also implements comparable and there is a compare to method in string object. So what you need to do is you need to use your m1 dot get message, that is get name dot compare to m2 dot get name. So what you are actually doing here, you are getting the name of the message, that is a string. On that string object, you are calling the compare to method and passing another string, so that this hello, hi, how are you, thank you will be compared each other and they return some int values. Based on those integer values, these things will be sorted. And now if I run the program, you can see first hello is removed and then hi is removed, because E comes first, then I comes, right? As H and H are same, it compares the next character. Next, let me again print and remove. Next, what it is removing? It is removing how are you. Let me again, the last one will be thank you. Well, this is what you are getting. Hello, hi, how are you? Then thank you. And the way I have added, the same way it is removing. But let us just interchange one object like this. Now this time what should happen is hello, hi, how are you? Then thank you should be removed, correct? If I run the program, you can see the same output. Hello, hi, how are you? Thank you. Uh, the I removed because the way I have added was in sorted order only. Let me add one more element. So I will just write here call me, and if I run the program, this time it is going to remove call me first, then hello, then hi, and then how are you, because we are using the comparator implementation telling that it has to compare two objects name in ascending order. If I want it in descending order, I can write m2 dot get name compare with m1 dot get name. This time it is going to be thank you first, then how are you, and then hi, then hello. So this way you can use priority queue. What you can try out as an exercise is try to create one order class with order ID, the name of the order, and the price or bidding price. And what you do is you create few order objects in the queue message and or queue order. You create a queue order and you add those order objects. Ensure that you have generated constructors, then setters, getters, toString, everything you generated, and then you create few order objects just like how I have created message objects, and you add order objects to the this queue message or queue order and try to poll so that it has to remove the highest price first to process. That way it can actually remove the elements in sorting order. Okay. Okay. So please try out this particular exercise. See you in the next video. Thank you so much.